In this video, we will do 3 separate examples. In each example, the given information will be the same. The video begins with a general overview of how to solve these type of problems. In each example to follow, you will be given a trig function evaluated at an angle, and you will want a trig function evaluated at an angle. To find the trig function at an angle, you will need to build a triangle on the bow tie. You will use the given trig function's answer and SOH CAH TOA to label one of the triangles on the bow tie with hypotenuse, opposite, and adjacent. You will only build one of the 4 right triangles on the bow tie. To decide where to build the triangle, you will use the acronym A, which stands for all, S, students, T, take, C, calculus. The acronym helps us remember which trig functions are positive in a given quadrant. A stands for all. The answer to all trig functions of an angle from quadrant 1 are positive. S stands for sine. The answer to sine of an angle from quadrant 2 is positive, and so is its reciprocal function, cosecant. T stands for tangent. The tangent of an angle from quadrant 3 is positive, and so is the reciprocal function, cotangent. C is for cosine. The cosine of an angle in quadrant 4 is positive, and so is its reciprocal function, secant. Get ready to use trig triangle in our first example. We are given the answer to the trig function sine of beta, and we want the answer to tangent of beta. We will need to build a triangle off the bow tie, so we will use the acronym All Students Take Calculus to decide where to build our triangle. Sine of angle beta is equal to a negative answer. This could only happen in quadrants 3 and 4. Cosine of angle beta is greater than 0, which is positive. This can only happen in quadrants 1 and 4. In quadrant 4, both of the given statements are true, so we draw our triangle in quadrant 4. Now that we've drawn our triangle, we want to label angle beta and then label the sides, hypotenuse, opposite, and adjacent. Using SOH and SOH CAH TOA, we know the denominator is the hypotenuse and the numerator is opposite. When we go to label the side lengths, know that the hypotenuse is always positive. The adjacent and the opposite can sometimes be positive and negative. It depends on the direction. The direction of opposite is down, so it is -4. Now that we know 2 out of 3 sides of the right triangle, we can use the Pythagorean Theorem to solve for the missing side. We will solve for the adjacent after substituting the hypotenuse and opposite and solving. Once we square root, we get the positive and -3. Because the direction of the adjacent is to the right, we know that this will be +3. The coordinate that I highlighted in blue would be 3, -4. Now that we know all 3 side lengths of the triangle, we can answer the original question, tangent of beta, which is opposite over adjacent. The answer is -4/3. For a second example, we will use the same given information, that the sine of beta is equal to -4/5 and the cosine of beta is greater than 0. but this time we want to find the answer to the tangent of beta over 2. If we were starting from scratch, we would have needed to use the given information to build a triangle on the bow tie and find all 3 sides of the right triangle. Looking up the half-angle formula, we find the tangent of beta over 2 is equal to positive and negative square root of 1 minus cosine beta over 1 plus cosine beta. The formula says plus or minus, but it is not both. At the end, we will decide if the answer is positive or negative. All we need is the answer to cosine of beta, and then we can substitute it into our formula. Using the CH in SOH CAH TOA, we know that the answer to the cosine of beta is adjacent over hypotenuse. In the right triangle, the adjacent is 3 and the hypotenuse is 5. Substituting 3/5 for cosine of beta, I get a fraction within a fraction. To get rid of the fraction within the fraction, multiply the numerator and denominator by 5. When you distribute 5 through the numerator and denominator, the fractions are gone. Then you simplify the numerator and denominator. Simplify the fraction 2/8. The square root of a fraction is the square root of the numerator over the square root of the denominator. We get positive and negative 1/2. We are finding the answer to the tangent of beta over 2. So to decide if the answer should be positive or negative, we need to determine the location of the angle measure beta over 2. Beta is in quadrant 4. If you take any angle measure in quadrant 4 and divide it by 2, you will find that you are in quadrant 2. For example, 300 degrees is in quadrant 4. If you divide that by 2, you get 150 degrees, which is in quadrant 2. In quadrant 2, only sine and its reciprocal function cosecant are positive. The tangent of beta over 2, an angle in quadrant 2, will be negative, so the answer is negative 1/2. Using the same given information as the first 2 examples, we want to find the cosine of 2 beta. Just as a reminder, if we were starting this problem from scratch, we would take the given information and use it to build a triangle on the bow tie. To evaluate the cosine of 2 beta, we need to pick one of the double angle formulas for cosine. There are 3 double angle formulas for cosine, but we only need one. For no particular reason, I'll use the top equation. The cosine of beta using CH in SOH CAH TOA is adjacent over hypotenuse. Looking at the right triangle off the bow tie, we see that adjacent over hypotenuse is 3/5. Substituting 3/5 in for cosine of beta, we need to keep in mind that cosine squared of beta really means cosine of beta multiplied by cosine of beta. After substituting, we begin to simplify, squaring the fraction, and then multiplying 9/25 by 2. When we go to subtract 1, we'll use 25 over 25, and the answer is negative 7 over 25.